Welcome back, children. How are you all? I think everyone is fine. So in yesterday's class we discussed about refraction. The bending of light rays when it is traveling from one medium to another medium is called as refraction, or the phenomenon of bending of light rays when it is traveling from one medium to another medium is called as refraction. And what is the cause for this refraction? It is change in the speed of light. So when the light is traveling from one medium to another medium, definitely there will be bending of light rays. So that is because of the change in the speed of light. So we discussed about even optical density. So speed of light is an indicator of its optical density. Higher the speed of light, you call it as optically rarer medium, and it has the lesser optical density. Lower the speed of light, optically denser medium, higher optical density. So we say that speed of light is an indicator of optical density. In today's class, we will discuss about the refractive index. So what is refractive index? The ratio of speed of light in a given pair of media. So here we are taking two different mediums. Yesterday I have shown you one activity where you have dipped the pencil in the water. So there are two different mediums. One is the air medium above the surface of water, and the second one is a water medium. So two mediums you have. Now you are comparing the refractive index. So in refractive index we have two different types. One is the relative refractive index, that is the relative refractive index of medium 2 with respect to medium 1 is denoted as mu 2 to 1 is equal to speed of light in medium 1 by speed of light in medium 2. So here medium 1 will be the optically rarer medium where the speed of light will be more, and medium 2 will be the optically denser medium where the speed of light is less. So here as we are taking two different mediums, we use this relative refractive index. Now we have one more definition which is coming under refractive index, that is absolute refractive index. So absolute refractive index we are denoting it as mu to m, where that is nothing but speed of light in vacuum by speed of light in given medium. So here I gave some speed of light in different mediums. So speed of light in vacuum is 3 and air is approximately 3, water 2.25, glass 2, diamond 1.25. So here the values which are more like 3, 2.25, these are all optically rarer medium, and where you have the speed of light is less, that is optically denser medium. So here when you are calculating absolute refractive index, one is compulsory speed of light in vacuum, that is 3, and speed of light in given medium, let me take it as water. So 3 by 2.25. When you do it, you get the absolute refractive index. So this is regarding refractive index. Now coming to what is the relationship between the refractive index and optical density. Refractive index is the indicator of its optical density. Means higher the refractive index, higher will be the optical density. Lesser the refractive index, lesser will be the optical density. So yesterday we even discussed that speed of light is an indicator of optical density. In the same way, refractive index is also an indicator of its optical density. So this is regarding the relationship between refractive index and optical density. In other words, we can say that refractive index and optical density are directly proportional to each other. Now, there are some rules of refraction. So what are the rules of refraction? You have to remember, when the first rule is, when the light ray is traveling from optically rarer medium, means higher speed of light, to optically denser medium, means lower speed of light. So when a light ray is traveling from optical rarer medium to optical denser medium, the light ray will bend towards the normal. So here you can see some dotted lines what I have drawn here. So this dotted lines are nothing but normal. So when the light ray is traveling from rarer to denser, the light ray moves towards the normal. So this is the first rule of refraction. The second rule of refraction is, when a light ray is traveling from denser to rarer. Denser means lower speed of light. Rarer means higher speed of light. So when it is moving from denser to rarer, it moves away from the normal. So here I have shown the yellow dotted lines which indicates the normal. So when it is moving from denser to rarer, it moves away from the normal. So these two are nothing but the two rules of refraction. The place where they bend, where they fall, that is nothing but called as interface. The surface where the bending takes place, that is called as interface. So once again, the two rules are, ray of light moving from denser to rarer, it moves away from the normal. The ray of light moving from rarer to denser, it moves towards the normal. So this is regarding the two rules of refraction. Hope you have understood what is refractive index, what do you mean by relative refractive index, absolute refractive index, and relationship between refractive index and optical density, and what are the two rules of refraction. Thank you children. Have a good day.